Okay, Matt, today I'm going to explain you about the Friedel Crafts alkylation versus Friedel Crafts acylation. And in case of Friedel Crafts acylation, you need to use little bit excess aluminum chloride. And what is the reason? Like why? Suppose if you want to put a alkyl group by Friedel Crafts alkylation, uh, one equivalent, you can use one equivalent aluminum chloride and the reaction should work very nicely. But even some people sometimes use little bit excess. But in case of acylation, if you want to put one acylation in the ring, so you have to use at least 1.5 equivalent to 2 equivalent of the aluminum chloride. What is the reason? Let's see the mechanism first for the Friedel Crafts alkylation. So suppose you are using this group like dimethyl or like propyl chloride. Okay, so in that case, the in Friedel Crafts alkylation you have to use the aluminum trichloride. So you know that its aluminum octet is not full. Like if you count 2 electron, 2 electron, 2 electron, so there are 6 electron. So aluminum is lack of 2 electron to fill the octet. So these chlorine will attack here and it will give you this chlorine positive charge with aluminum like this, and ultimately your methyl group, another methyl group, and then it will give you two different things. Like one is this carbocation, like one CH3H and CH3. So this will break down. So it will be a carbocation, stable carbocation, plus that aluminum chloride, and since it get this additional chloride, so it will form a negative, like tetrachloroaluminum ion. So it produces this aluminum chloride helping, like taking out this chloro to make this carbon as a carbocation, and that carbocation will be taken by the aromatic ring, like for the electrophilic substitution reaction. Let's see how it happens. So just keep in mind you have this carbocation and also this like alumina tetrachloroaluminum negative ion. So now when you have aromatic ring and your that carbocation is close by, like methyl, hydrogen and methyl, so these electron will go to this carbon, okay, and ultimately it will form like this. And remember, all of this carbon has one single hydrogen, okay? So this hydrogen will be there, and since it is attacking there, like giving this double bonded electron, so it will form like this, CH3 hydrogen, CH3, and since this bond is broken, so it will be positive in charge and this thing. And by resonance, you know that all of you know that these electron will go here and ultimately it will go there to satiate this positive charge, and ultimately there will be a positive charge here, and again to remove this positive charge this electron can move. So ultimately that is a resonance structure, and in that case you can write the whole thing like this is resonance structure. So we can write the structure like this, so that electron can move with the positive charge. So we can say, okay, this is like this. All of you obviously know this structure, and this is called sigma complex. So this sigma complex go back, and this additional hydrogen now will be taken by this that aluminum Cl4 minus I showed you last time. So that will take this hydrogen, and that hydrogen and carbon electron will go to this ring, and ultimately your product will convert to alkylated product. So it will fulfill the ring, and ultimately your product will be like this. So, and definitely aluminum chloride will come back, and one extra chlorine will be taken by this H, so it will form the HCl. So this is the final reaction for the Friedel Crafts alkylation. And if you look on this mechanism, it reacting of like from the beginning, it reacting only one equivalent aluminum chloride to take out that chlorine from the alkyl halide product to make the carbocation, and ultimately finally it is taking the one hydrogen to give this HCl, and it is coming back as aluminum chloride, and it will work in the reaction as a catalytic cycle. Okay, so there is like just one aluminum chloride is enough. So now just go to the Friedel Crafts acylation reaction, then you can understand why that reaction requires more than one equivalent, even if you want to put one group in the one acylated group in the ring. Okay, now you want to put a acyl group, suppose chlorine, in the acylation. Like suppose you have a benzene ring and you add this with the aluminum chloride, plus this and this. So you want to make, just we are taking simple example. So we want to make this acylated group. Okay, so what is the first mechanism? So let's see how it happened. So in this reaction, first with the aluminum chloride, it formed a like complex, this carbonyl group and this chlorine. So it has two like electrons. So there's aluminum chloride always has like less electron than the octet. So it will form AlCl3. This oxygen is positive, and definitely this carbon chlorine bond is delta negative, like less, more electron here. So in that case, it will remove this chlorine to form a carbocation, like this carbon oxygen carbocation. Okay, and it can be also form like this carbon triple bond R, and that oxygen electron will be used, so like this. Okay, plus your aluminum chloride and one extra chlorine from here, that chlorine will be taken by this. So that's why this aluminum will be negative in charge. So remember this part. Okay, now your carbocation, either these or that, so their resonance, so this carbon will be taken by this ring. So let's see now with the benzene ring, and suppose we are taking this as a consideration, that electron will be given to this carbon. Okay, and now what will be the immediate intermediate? So the same as a alkylation. So these will be hydrogen and this carbon, and it will be a double bonded like that, and R, and again the positive charge. And since again I said like this electron can go here, so next resonance structure could be like this, and this electron here and positive there, H, carbon, oxygen, R, and then that electron go here, and since it is going there, a positive charge will be producing here, so that can be rotated like this. So ultimately this is also another sigma complex, so you can draw like this. That is called sigma complex. Okay, so once this sigma complex formed, again here one hydrogen is there and the ring is shortage of electron. Okay, so what it can do, it will form, let's draw from here. So we have this structure, we have this structure, so it will go down like this. It will form this R plus H plus, and from these, that aluminum tetrachloride, Cl4 minus, will take this hydrogen out. So it will form these R plus that one, this hydrogen will take out one AlCl, but remaining from there, remember now it is the point to focus, this remaining aluminum chloride AlCl3 will make a complex with these oxygen. I should make a bigger structure actually. So here that AlCl3, it will form a complex in this carbonyl group. This is the important part, and you will get ACl. Since these aluminum chloride is forming the complex with this carbonyl, that's why some aluminum chloride will be used up to form the complex. You understand? Like if you use exactly one equivalent, suppose you need 100 aluminum chloride for the reaction, and some of the aluminum chloride is getting complex here with the product or whatever the carbonyl group you are using. So it is forming a carbonyl group, and that carbonyl group is forming some complex with the aluminum chloride. That's why some of will be used up in this reaction, and that's why it will require more of it to keep going the cycle, catalytic cycle. You understand what I'm saying?
So if you do exact 1-to-1 ratio, that
Then
will be trapped.
some of them will be trapped with the product carbonyl group.
And then you'll
It will
have
form
some
the
starting
complex.
material.
And you will have some starting material left over because it will not get enough aluminum chloride. That's the reason for the Friedel Crafts acylation. You have to use like excess aluminum chloride than the alkylation.
It's because of that oxygen, that carbonyl, right? That's
Yeah,
the
so
reason.
it will go a certain mechanism for that.
What exactly does the complex look like between the carbonyl and the AlCl3?
So that's why I'm saying like this oxygen electron has
Electropositive.
like, so that electron is given to this aluminum. So that's why it is forming like kind of positive charge.
That's a partial positive, right? With that symbol. Was that delta?
No, here we cannot show the partial because it is really sharing two electrons with the aluminum.
Oh, it is. Okay.
Hold on a second. Okay. So now that electron go here and that electron will be going there. So you can say like resonance type structure. So you will get again the positive charge here, and it will be double bonded and R, and that oxygen will be neutral again with that aluminum chloride AlCl3.
There we go.
Negative. Okay. And then it will go like different resonance structure. So sorry, here. So that electron go here and ultimately go there. Another positive will be there. Another positive will be there. So by this way, it happen like resonance structure. So I can draw another structure actually. So that could be like this, and positive charge here, and this carbon or oxygen, aluminum chloride, R.
And now the moment of truth. The annoying part of isolating the product you actually want.
So now these are complex actually, AlCl3 minus and positive here. So here finally it formed the complex. As long as it produced the product, it formed the complex, and then it will take in presence of water, hydrolysis or something. So that aluminum chloride will be gone. Like once your reaction is done, so you can quench your reaction with the water. So water will help out to take out your aluminum chloride from your original carbonyl compound product. So it will form aluminum hydroxide and acidic solution and also chloride solution. So you can maybe take 4 of something, whatever. So these are the like side product which is like water soluble. It will be gone and you will get your final product as a acyl product. So the point here is you already see from the mechanism alkylation versus the acylation. So in case of acylated product, you will see some of the aluminum chloride is getting used up or making complex with the produced carbonyl product, and that's why you need more excess of the aluminum chloride. But while for the okay, so these are the things you need to know, like it is forming carbonyl group, produced carbonyl compound and forming the complex with the aluminum chloride, so that's why you have to use more excess than the one equivalent. If you want to add more than one equivalent in the group, like acylation, like multiple acylation, so in that case always use like at least 1.5 equivalent per acylation of a molecule. Okay, so these kind of reactions are very important. You can also use many other acylation, like using oxalyl chloride, that is also used for the Friedel Crafts acylation. So what is it actually? So oxalyl chloride, I guess this is also oxalyl chloride. So if you want to use one half of this, like stay same as this, so in some cases people do directly oxalyl chloride like immediate acylation. After that they use, in case of in the in situ reaction, I guess they use amine or dimethylamine to make. Suppose you want to make these kind of things, okay, so you can make these like this in situ, and immediately if you use amine group like dimethylamine, so that will be, that nitrogen will be attached here, so you can make
Yeah, and it doesn't have to be dimethylamine, right? It could just
yeah,
it could be one
amine or
methyl.
anything, okay,
Yeah,
so
okay.
you can make it.
Yeah.
So what is the reaction name you said?
Friedel Crafts Acylation?
No, the
Oh, speeder Antony tryptamine synthesis.
yes,
Yeah.
so yeah, people use this kind of reaction for that tryptamine synthesis or anything, so you can just do the reduction after that, so you will get the
Lithium aluminum hydride reflux, and you grab that.
okay. So the most important point I was trying to say for this acylation amount of aluminum chloride. So I hope it will help you to understand. So if you have any question on Friedel Crafts acylation and alkylation, then you can ask me in the comment, and I will happy to answer it. And stay fine up to the next video. Thank you for supporting my channel by subscribing, and who didn't subscribe my channel yet, please do it. I'll get more inspiration to do more video. Bye now.